MS Ramaiah University of Applied Sciences.
Hi students, let us discuss centrifugal blower. Centrifugal blower is a turbo machine commonly used in forced or induced draft in industries handling air, smoke or other gases. They are frequently used in heating, ventilation and air conditioning (HVAC), power plants, furnaces and process industries. Fans, blowers and compressors are commonly used in air or gas handling equipment. Based on the construction, we can broadly classify these power absorbing devices into rotordynamic devices, positive displacement devices. Rotordynamic devices are classified based on the pressure ratio. Fan has a pressure ratio up to 1.11. Blowers generally have pressure ratio range from 1.11 to 1.2. Compressor range in pressure starting from ratio from 1.2. According to the direction of flow, rotordynamics devices are classified into axial fans, blowers and compressors, radial or centrifugal blowers, fans and compressors. Centrifugal blowers are similar to centrifugal fans in construction. Centrifugal blower has three main components. Volute casing. A volute casing is a flow passage that has an increasing cross-sectional area along the fluid flow direction. This design increases the static pressure of the fluid at the expense of its velocity. The volute casing can replace the function of a diffuser in blower applications with low fluid discharge requirement. The study of static pressure increase in the blade passages and volute casing is important in understanding the working of centrifugal blowers. Rotating impellers impart centrifugal force to the fluid, but the shape of the blade passages increase the fluid static pressure. Static pressure rise in the impeller blade passages. The total pressure, that is stagnation pressure, is same from inlet to outlet. PO1 is equal to PO2. Substituting the static pressure and velocity values, we get P1 plus V1 square by 2 is equal to P2 plus V2 square by 2. The mass conservation relates the area and fluid velocity as A1 V1 is equal to A2 V2. From the above equation, we can see that the static pressure of fluid increases similar to diffuser. Therefore, blower increases the static pressure at the expense of velocity.
Hello everyone. Today we will be conducting an experiment on centrifugal air blower test rig. In this experiment, we can conduct the experiment on three different types of vanes. One is a radial, another is a forward curved and the other one is a backward curved vanes. The experimental setup consists of a centrifugal blower. The centrifugal blower is being driven by a three-phase electric motor via a V-belt shaft. This is the shaft of the centrifugal blower, on which a proximity sensor is placed to measure the speed of the shaft. For the centrifugal blower, the air enters axially over here, and there is a tube connected at the inlet which is further connected to a U-tube manometer which will give the suction head of the air entering the blower. After the delivery, the air comes out tangentially in this pipeline. This is the delivery line. on this line we have another pipe connected, which is again connected to another manometer, which will give the delivery head of the air exiting the blower. On the delivery line, a pipe is connected to another manometer, which will give the delivery head. Further on the delivery line, we have a venturi meter to measure the discharge of the air flowing through the circuit. Here we have a pipe connected at the inlet of the venturi and another pipe connected at the throat of the venturi to measure differential pressure through the venturi meter. Further, we are having a delivery valve, which is a butterfly valve to control the flow rate of the air flowing through the pipeline. On the panel, we have an energy meter using which we can know what is the power that the electric motor is being consumed. And we have an RPM indicator which will give the speed of the shaft of the blower. We know that a pipe coming from the inlet of the blower, which will give the suction head at the inlet, is connected to the U-tube manometer over here. The manometer is having water as the manometric fluid. The other limb of the manometer is exposed to the atmosphere. So we will know whatever the reading that we are getting from the manometer will be the gauge reading. Similarly to the suction head, the delivery pipe coming from the delivery line is connected to the U-tube manometer over here. Here also we are having water as the manometric fluid. So the suction and the delivery head can be measured in terms of meters of water column. From the venturi meter, the pipe coming from the inlet and the throat is connected to the differential manometer over here. Here also we are having water as the manometric fluid. Here we will measure the pressure difference in terms of meters of water, which can be used to calculate the discharge of the air flowing through the pipeline. Before starting the experiment, we have to switch on the main switch, which is present behind the experimental setup, and afterwards we have to remove the lock pin on this blower switch and then switch on the blower. I have connected a forward curved vane inside the blower, and we can see the speed of the shaft of the blower over here. It is showing a value of around 1760 RPM. The differential pressure of the venturi meter can be observed in the difference of the water column over here. The delivery head of the blower from the delivery line can be measured on this manometer, where the levels of the water can be seen over here. Similarly, the suction head of the air entering the blower can be measured by seeing the levels difference of the manometer over here. We must observe that at the delivery head, the level in the left limb is lower than the level in the right limb. in contrast to the suction head, where the level in the left limb is a bit higher when compared to the level in the right limb. This indicates that the suction head is negative pressure, that is, the pressure at the suction is lower than the atmospheric pressure. The power consumed by the electric motor can be calculated by noting down time for a particular number of blinks on the energy meter. Now, one set of readings has been taken. The next set of readings can be taken by closing a discharge valve. Initially, the valve was 100% open. We can close the discharge valve for 75%, 50% and 25% and then repeat the same experiment. The experiment was conducted with a forward curved vane attached to the blower. Now, the same experiment can be repeated with a radial vane as well as a backward curved vane which can be attached to the blower. Now, once all the readings have been taken, we calculate what is the discharge as well as the head of the air that is entering and exiting the blower, using which we can calculate what is the efficiency of the blower and also plot a graph of discharge versus head for the blower. And that concludes the experiment.
At MSR UAS, we spark your imagination unlike any other.